Okay, so then in our previous segment, we talked about the explosion, where we started with one object and then it blew apart into two objects. And we used conservation of momentum to be able to predict the speed of one of those objects that went flying off. Now what we want to do is start with two objects, and they're going to come together and they're going to stick together. So we're going to say that this is going to be a totally inelastic collision. In an inelastic collision, they're going to stick together. And so we're going to be able to say that the initial momentum of the system is going to equal the final momentum of the system. Okay, this time we're going to have two initial momentums. So we're going to have the initial momentum for particle 1 and the initial momentum of particle 2, and then after they're stuck together, that's then going to be the final momentum of the system. And then we can substitute in, well, what does momentum mean? It's going to be mv, so that we're going to have the mass of particle 1 times the initial velocity of particle number 1 plus the mass of particle number 2 times the initial velocity of particle number 2, and then that's got to equal the total mass when they're all stuck together times their total speed. So let's look at an example of this using our simulation. So this time we want to go to the inelastic collision. And then I'm going to reset it. All right, now my initial velocity is going to be, for the red car, 0, and my initial velocity for the blue car is going to be 0. And then here are the masses, and so let's go ahead and start it up and see what happens. Not very exciting. All right, we've got to give the two carts some initial speed, or else they're not going to collide with each other. We also have to be very careful because let me go ahead and reset this, and let's just say, for the sake of argument, that I give the blue or the red one a speed of -2, and I give the blue one a speed of -2. What do you think is going to happen? Are they going to collide? All right, let's go ahead and hit the go button and see what happens. Well, that's not very good either, because they're just chasing each other. So we need to give them some pretty good speeds in order to do this. So let's give the red one a positive velocity. All right, so let me give him a positive velocity of 4. So what direction is the red one going to go in? Positive means to the right. The blue one's going to have a negative velocity, so this time they are going to collide. Okay, so let's go ahead and hit the go button and see what happens. Okay, so they did collide and they did stick together, and now they have a combined speed of 2 meters per second to the right. So let's use our formula and verify that this is conservation of momentum. So we're going to have the mass of the red car, so mass of R for red, and then the velocity of the red car, initial, plus the mass of the blue car, and then the velocity of the blue car, initial, and then that's going to be equal to, now they're going to be stuck together, so then we want the total mass and then the final speed when they're stuck together. So let's plug in some numbers here. The mass of the red car was equal to 2. The velocity of the red car was equal to 4, plus the mass of the blue one was 1, and then the velocity of the blue one was -2, and then this is going to be equal to, now the total mass is going to be 2 plus 1, which is going to be 3, and then it turned out that the speed was 2. So let's see if that was verified. So 2 times 4 is going to be 8, plus, okay, 1 times -2 is going to be -2, and then 3 times 2 is going to be 6. So 8 minus 2 is going to be 6. 6 is equal to 6, so momentum is going to be conserved. All right, now let's go back to the notes here and do a word problem that deals with this. Okay, you have a 100 kilogram quarterback is running to the right at 8.9 meters per second. He is hit by a 150 kilogram linebacker traveling at 8 meters per second to the left. They're then going to stick together. So the linebacker is going to wrap his arms around the quarterback so that they're going to move as a unit. So what would be their final speed? So we're going to set the initial momentum equal to the final momentum. We're going to have the initial momentum of the quarterback. We're going to have the initial momentum of the linebacker, and then that's going to equal the momentum when they're all stuck together. So we're going to say that the momentum of the quarterback is the mass of the quarterback times the speed of the quarterback, which is going to be 890, and then the mass of the linebacker times the speed of the linebacker. And notice that we used a -8 because the linebacker is going to the left. And so that's going to be -1200, and then that's going to equal their total mass. So 100 plus 150 is 250. And then we're going to add it together. So 890 minus 1200 and then divided by 250 turns out to be -1.24 meters per second. So what does that mean? After the collision, the quarterback and the linebacker are moving backwards. So that's how you could use this formula in order to solve a word problem. Okay, so we have now done the explosion, we've done the collision. So now in our final segment we're going to talk about the elastic collision, where they're going to come together and then bounce off of each other.